Okay, so this is an equilibrium problem, and we're going to solve it using our ideas of torque and force. So your form may be modeled as a uniform rod of length 0.4 meters and of weight 10 newtons free to pivot about your elbow. Your biceps is connected to your form at a point 0.04 meters from your elbow and exerts a force vertically upward. Determine the force that your biceps must exert to maintain your form in equilibrium in the horizontal orientation shown. So the first thing we need to know is that whenever you have a uniform rod, the weight force is going to be acting at the center of that rod. So the weight is 10 newtons, and now that gives us a new distance from the pivot point of 0.20 meters. Now let's draw in our force biceps, which is considerably closer. So our main concept here is that the sum of the torques is equal to 0, and for each force, the torque will be equal to r, the distance from the pivot point, times the perpendicular component of the force. And in this case, the forces are perpendicular, so we don't have to worry about any trig. So for this problem, torque weight plus torque bicep equals 0. So torque weight is going to be 0.2 meters for our R times 10 newtons, and that'll be actually a negative 10 newtons. It's pointing down, plus 0.040 meters for an R, and our unknown is F bicep. That equals 0. So we can multiply this and bring it over, and so we'll have over here, I believe, 2 Newton meters. And if we divide 2 by 0.040, I think we're going to get for our F bicep 50 newtons. Okay, so we figured out what the force our bicep has to exert to maintain our arm in equilibrium. Now we want to know, what is our elbow doing? So of course the elbow is not exerting any torque because its distance from the pivot point is 0. The elbow is the pivot point. But it doesn't mean it can't be exerting a force, and I think it is. So our arm is not accelerating at all in the up or down direction. So we know that F net has got to be 0. There's no acceleration. So we can go ahead and add up our forces and figure out what the force of the elbow is. So we're going to have F elbow plus F bicep plus weight equals 0. So F elbow is what we're looking for, plus 50 newtons, it's positive, minus 10 newtons. Weight's going to be negative, it's pointing down, 10 newtons. So we can see that the F elbow will come out to be negative 40 newtons. And this makes sense because we found that our bicep is pulling with a 50 Newton force in the upwards direction, but we only have 10 newtons acting down. So if we're going to have 0 acceleration in the y direction, we're going to have a negative 40 Newton force from our elbow.